Okay, so welcome to section 4.3. This is transformations. Transformations of trigonometric graphs. Trigonometric graphs. Okay, so let's recall that f of x, and then on the outside plus k, shifts the graph of f of x, k units, upward, for k being a positive number, whereas f of x minus k shifts the graph of f of x, k units downward if k is positive, k units downward for k a positive number. So for example, let's use this fact to plot our sine and cosine functions. So for example, let's plot the graph of, let's have f of theta be, what shall we do? Let's do 2 sine of the quantity 3 theta, then on the outside of the function minus 1. So let me rewrite the function. So we have f of theta is equal to 2 times sine of the quantity 3 theta minus 1. So I know that my amplitude, A, is 2. That comes from here. I know that my period, P, is going to be 2 pi divided by the coefficient of theta, 3. And now I have something additional. I have minus 1. So minus 1 would be down 1. Okay, so what I'm going to do is I'm going to first plot the graph of 2 sine of 3 theta, then I'll move it down. So theta versus f of theta coordinate axes. Let's see. Theta versus f of theta. I'll try and make this a bit smaller than usual. Looks like I need to move this up a bit. Okay, let's do 1, 2, 3, 4 quadrants to the right. We have an amplitude of 2. And 1, 2, 3, 4 quadrants to the left. I know that my period is 2 pi divided now by 3. So each of my quadrants, of course, is divided by 3. So pi over 2 divided by 3, pi divided by 3, and 3 pi over 2 divided by 3. So going left, this corresponds to negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3, with an amplitude of 1, 2, negative 1, negative 2, and negative 3. So normally sine would start at 0, go up to amplitude, which in this case is 2, back down to 0, down to negative amplitude, and back to 0. And it has rotational symmetry. So sine prior to the vertical translation with an amplitude of 2 would look something like so. Not drawn very well. Okay, but I want to shift each of these points that I plotted, the quadrantal points. Let's shift them down 1. So each of the points that I plotted, I'm going to shift down 1 unit, because the minus 1 does that, and we're subtracting 1 from the y coordinate. Okay, so now we can connect the dots with the final graph. Okay, there we are. So that would be 2 sine of the quantity 3 theta minus 1. Okay, let's do another example. Let's see, how much room do I have here? Looks like I can do it. So for example, let's plot f of theta is equal to secant of 5 theta minus, or let's do plus 2. I already did minus. So in this case, the amplitude, of course, is still 1. The period, p, is 2 pi divided by 5, the coefficient of theta. And I notice on the outside I have a plus 2, so that's going to be up 2. But remember, for the reciprocal functions, we consider g of theta being equal to cosine of 5 theta. Okay, I'm just going to consider that for the moment, not the vertical translation. So theta versus f of theta coordinate axes. And in this case, I can put my horizontal axis a bit lower. Oh, did I not label my axes? I didn't. Oh my goodness, shame on me. Okay, so theta versus f of theta coordinate axes. I'm going to break this up into 1, 2, 3, 4 quadrants to the right, or 1, 2, 3, 4 quadrants to the left. My amplitude is 1, but I know I'm going to be going up 2 units, so I'll put a couple more tick marks. So my period was 2 pi divided by the coefficient, which was 5, the coefficient of theta, that is. So each of my quadrants will be divided by the coefficient of theta. Hence I divide each by 5. And this, of course, corresponds to negative pi over 10, negative pi over 5, negative 3 pi over 10, and last but not least, negative 2 pi over 5. Okay, so I know that I use the graph of cosine to plot the graph of secant. So let me do this. Cosine would start at amplitude and is symmetric with respect to the y-axis. That is, it's a mirror image on either side. So cosine of 5 theta would look like so. Okay. Now, I'm moving up or down, so I know that my vertical asymptotes aren't going to shift. So my vertical asymptotes are still going to be wherever I go through, or the graph of cosine goes through. The x-axis, that is, its value is 0. Okay, so normally cosecant would meet at the peaks and the troughs and go off asymptotically towards the asymptotes. However, I'm shifting this graph up. Sorry, did I say cosecant? I meant secant. So I'm shifting this graph up 2 units, right? Because of this plus 2. So therefore, each of these points, say the point at 1 all the way to the left here, gets shifted up 2 units to 3. The shift down here, the point down here at -1 will go up 2 units to 1. Actually, that's supposed to be 1, not above 1. Similarly, this point here at positive 1 is going to go up to 3. Everything is shifted up 2 units. This point down here at negative 1 goes to positive 1. And finally, this point here at positive 1 is going to go up to 3. So let's note something about the domain and the range, most importantly. So the domain, of course, excludes all value of theta for which there's a vertical asymptote. So that looks like theta cannot be equal to pi over 10 plus the distance between asymptotes is pi over 5. So any integer multiple of pi over 5, plus or minus. But the range is what's changed here. Notice my range goes from 1 all the way down to minus infinite. So from bottommost number, minus infinite, to topmost number, 1 inclusive. But then I start again at positive 3 and go all the way up to the infinite, so 3 to the infinite. So let me do that same analysis up here. Of course, for sine and cosine, the domain is really nice. The domain is simply all real numbers. Don't have to think about that one. But the range here is what has changed. Notice that we've gone from negative 3 to 1 as far as our values for y on the whole domain. So that would be negative 3 to 1. Okay, I hope this is making somewhat of sense. I know it's hard when I'm not there in class, but hopefully this will work.